right, so now let's go over problem 8. And this one states, well, part A. Prove a formula similar to the one in problem 7a, but involving a arc cotangent instead of arctan, or arctangent. And then part B says, find the sum of the series, summation from n equals 0 to infinity, of arc cotangent of n squared plus n plus 1. Alright, so let's take a look at question A and look at the solution to it. So solution to A, first recall from problem 7a that we started off with the tan x minus y trigonometric identity. So again, we're going to look at problem 7a, but switch it up to using arc cotangent instead of arctan. So if we scroll all the way up to our 7a, so in 7a, how far did we go? Yeah, it keeps going. So we were asked to show this arctan x minus arctan y equals to x minus y divided by 1 plus xy. So we want a similar formula, but instead of arctan, we use arc cotangent. And if you look at the solution, remember when we used this identity, so first we wrote this as a minus b as theta, and then we used the identity right here, tan x minus y. So we'll start from this, and we're going to switch it up to cotangent, and then from there get arc cotangent, similar to the solution to A. Alright, so teleporting over to here, so solution to A. So recall from problem 7a that we started off with the tan x minus y trigonometric identity. So again, this one right here. And let's use the same identity, but convert it to the form with arc cotangent. So first off, let A equals to arc cotangent of x, and we'll let B equals to arc cotangent of y, like that. And this is for, let's say it's defined for 0 is less than a minus b, less than pi. And notice here, this one is, this domain is from 0 to pi, as opposed to the earlier one for tan was a negative pi to pi. So if I scroll all the way back up to our graph here, so we had it from negative pi to pi. And this is arctangent. And just a note here, and I'm just going to draw this in red. Notice here, so when we do the inverse, we're basically switching x and y. So then this is theta there. This becomes theta on the arctan setup over there. Or I just put that there just to show that this switches over to this side here, and so on. And then you're going to be defining theta according to that setup there. So anyways, I'm just going to erase that. Alright, so then remember this one is between negative pi over 2 to pi over 2. That's because of the tan was set up over like this. The arctan is, so tangent is defined from here, but it's periodic. And then this arctangent will just go from negative pi over 2 to pi over 2, and it only just once, so you'll have it as a one-to-one function. So that instead of doing this multiple times like that, you're gonna have, then you'll have a theta, and then you'll have a y1, y2, etc. So we can't do that, so we need to make it all one-to-one. And so we'll just pick that just this domain becomes the range right there. Alright, so going over here, now in our case, we're going to be dealing with cotangent instead of tangent, and then we'll show the corresponding domain of that. So, alright, so now we're just going to do a refresher on inverse functions. It'll pretty much it becomes that. So recall first of all that cotangent theta is equal to 1 divided by tan theta. So that means then first we gotta show the graph for tan theta, then cotan theta, then we'll look at arc cotangent. So if we have a theta like that, and this right here goes up, so this is, well, first, this goes up like this. Just you can have this ingrained into my brain. The curve for the tan, this is at pi over 2, and this is at negative pi over 2, and this right here is our tan theta, like that. And then the next setup is at pi, And so you have this pi over 2, add another pi over 2, and that becomes, add another pi over 2 becomes over here. Let's put a pi. This is at a 0, and actually no, I got that mixed up. So add another pi over 2 becomes over here. Let's just do one more time here, and then add another one, it becomes 3 pi over 2 right here. And yeah, 3 pi over 2. And notice it's going to basically reflect again. It's basically, it's periodic, so it repeats again and goes like that, and so on. And then if we go one more here, this is at negative pi over 2, like that. Actually, no, we already have negative pi over 2. We don't need to keep going further. Yeah, that's just right here. So now, if I draw in red, let's go here in red. Okay, so I'm going to draw in red now for cotangents. Remember, cotangent is 1 divided by tan. So then over here, as it goes to infinity, we are going to, basically as it goes to infinity, it's actually going to 0. And as it goes to 0, you'll have 1 divided by infinity, so that goes over like that. And likewise, over here at this pi, I'm going to draw this down here. And then this is going to go downwards like that. And likewise over at this point right here, at this point it's going to be on the positive. This is on the negative side, it's on the positive over like this. And this goes to the 0 there. Yeah, that goes 0 as tan goes to infinity. And again, I'll just put this as, this is at cotangent theta. And then the next setup is over here 0, but it's at the negative, so that means it's going downwards. And then this is at infinity goes to, well, 1 over infinity goes to 0. Like that. Let's make this a bit better. And like this. Alright, so that is where it is. And then to get a one-to-one function of the arc, or the inverse cotangent, we're going to have to look at, well, typically what's picked is this section right here from 0 to pi. It's from 0, theta less than pi. And we're going to take this section and then do the inverse of it. So, put it down here, we're going to get a function that looks like this. So let's just write this out here. This is our theta. And now we're going to draw that same curve. So this is at 0, and this is at pi. I'll say pi is here. And then dot, dot, dot. And it goes like this. This is at pi over 2. And it goes to infinity. And it goes down. And this right here is our cotangent theta, like that. And now we're going to draw the arc cotangent. So basically we switch everything. We switch this. If this is theta, the new theta will go over there, and so on. And I'm just going to erase that just because you switch them, but then you redefine the variables. Alright, so let's just extend this further, and this is at our pi. So we go from the asymptote as the vertical becomes horizontal when you take an inverse, and then this pi over 2 becomes over here is the 0. This becomes pi over 2, and yeah, this is our pi over 2. And notice what happens here. We just switch the x and y's. So at theta is approaching pi, cotangent goes to infinity. That means the reverse would be as arc cotangent, or the inverse cotangent, goes to infinity. I mean, as the theta, the x coordinate goes to infinity, or the theta coordinate, then it approaches pi. And it's not just infinity; it's negative infinity. So you have a negative infinity there. So you go to negative infinity, so if we basically rewrite this again. So if we're approaching pi, we go to negative infinity. So then we'll have to go to the reverse. We have to approach negative infinity, approaches pi. So that means we go negative infinity, approaches pi right here. So that's this part right here. So that, and then it goes over to here. So that means it's going to go like this to negative infinity. And then likewise over on this side, we're approaching 0. So as x goes to 0, theta goes to 0, we're approaching positive infinity. And then the other way around is go to x goes to infinity, or a horizontal coordinate goes to infinity, then this approaches 0. So then this goes like this. Yeah, so this approaches this setup there, like that. Alright, yeah, just move things around, and now this one is the inverse or arc cotangent theta. And notice how the domain of the cotangent is from 0 to pi, or that's the range we're looking at. Because notice it keeps repeating, we're only looking at this one, so then that means this vertical range is going to be from 0 to, this is theta, is pi. So that is what it's defined for, so that it's a one-to-one function. So for each theta, you only have one arc cotangent theta here, and not multiple ones on the top or the bottom, etc. Otherwise, you'll have a non-one-to-one function. Anyways, let's remove all that. And all right, now that we have that, basically recap on inverse functions and where the range / domain is. So we have this setup here. So that's where it's defined for, where the a minus b is like that, and that's because we're going to be taking the arc tangent of it soon. And also, so let's take a look right here. So tan x minus y, we're going to use that identity. Yes, tan x minus y is equal to tan x minus tan y plus, and then divided by 1 plus tan x times tan y. But instead, we're going to look at the cotangent version. So I'm going to write thus. Thus, what we'll have is cotangent a minus b is equal to, by definition, 1 over tan a minus b. And this equals to, basically, we'll take that tan a minus tan b. So this one, but then we'll flip it upside down. So we'll just go over it because we're doing the reciprocal of that. So this equals to 1 plus tan a times tan b. This was originally the bottom. Tan b divided by tan b minus tan a. Actually, no, we got that mixed up. It's tan a minus tan b. As you can see that here, tan x minus tan b, and so on. All right, yeah, so let's continue further. So we have this setup right here. And now what I'll do is, well, rewrite this all also in cotangent version. So so this equals to 1 plus 1 over cotangent a. So cot a times by 1 over cotangent b. I'll divide this by tan a becomes 1 over cotangent a minus 1 over cotangent b, like that. And now what I'll do is multiply the top and bottom by cotangent a. Yeah, cotangent a times cotangent b, just so we can have this denominator the same, and then do a whole bunch of cancellations. Cotangent, and then divide it also by a cotangent a times cotangent b. So we're not changing anything because this is just multiplied by 1. So now what we'll do is do a bunch of cancellations. So this equals to cotangent a times cotangent b. So that's a 1 over here, and this part cancels out. We're going to be left with 1. And then divide this by, right here, 1 over cotangent a cancels, so we're going to be left with 1 over, not 1 over, just we're going to be left with cotangent b. And then minus cotangent a, like that. And now what we'll do is I'm going to move the 1 in front, equals 1, plus, and then we're going to place our a and b. Remember, our a is equal to arc cotangent x, and our b is equal to arc cotangent y. So what we get is 1 plus cotangent arc cot x times by by cotangent of arc cot, this is going to be y. I'll divide this by arc cot of, it's cotangent of arc. Cotangent arc cot of x minus cotangent, oops, I'll remove this one, cot arc cotangent y. I mean, this one's y. This one's y. This one's x, because that's b, and that other one is a. And now, recall what we did with the tangents. The same thing for cotangent or any other trigonometric and inverse trigonometric function. So this becomes right here, this whole thing is just x. This whole thing is just y. And cotangent of this, again, is just y. This is just x. Yeah, so what we get is thus, and I'll just put this, this is a cotangent a minus b equals to, so cot a minus b is equal to 1 plus xy over y minus x, like that. And yeah, that is pretty amazing. So that is that. And now we're going to take the arccotangent. So since we defined it as theta is between a minus b, or thetas are a minus b, is between 0 and pi, then we could take the cotangent of both sides. So since it's that, we have arc. So just take the arccotangent of both sides, or obviously just switch this over. This equals to the arccotangent of this. But just for completeness, and also do this another way. So arc, and notice that arc, the word arc derives from just the arc. So that's the arc, or theta. So that, hence the arccotangent. And usually, and that's why it's called arc, as you're going to be equaling to this theta, which is this a minus b inside this cotangent. So arccotangent of cotangent a minus b, like that. So we're going to arccotangent of both sides. You could also do it that way. Arccotangent of 1 plus xy, and then y minus x, like that. And now this, again, this just equals to a minus b, like that. And same thing if you have a cot or arccot, and it's the same thing. So this cotangent of this, or arccotangent of a cot, mix those around, it'd be the same thing. You look at the inside angle there. And now this means is a minus b is equal to arc, or actually let's put the whole thing. So a is arc cotangent of x minus arc cotangent of y, and then this equals to arc cotangent of 1 plus xy over 1 plus xy over y minus x, like that. And let's box this whole thing. So there is our similar formula to the tangent one, or the arctangent, but now we're dealing with we're dealing with arccotangent. All right, and now that we have that, now let's continue further and look at the solution to question B. So let's look at question B right here. So question B says, find the sum of this series, summation from n equals 0 to infinity of arc cotangent of n squared plus n plus 1, like this. And what we could do is notice this polynomial inside n squared plus n plus 1. Put that a bit better. N squared. Oh, let's try it one more time. N squared. All right. So we have that. And what we could do is let's look at the solution to part B. So we can reformulate the polynomial inside arccotangent to match our identity from part A. So we could look at that and match it with this right here. And we could see that by, well, if we do some algebraic manipulation. So n squared, let's go n squared plus n plus 1 is equal to, let's factor out the n from these two terms. So this equals to n times by n plus 1. So n, just take that out. N times n plus 1 plus 1. So notice that this looks like this one, 1 plus xy. And I'm going to write this as, put the 1 in front, 1 plus n times n plus 1. Divide this by, now we need a y minus x. And notice again, if this is our x, if this is our y, then what we'll have is n plus 1 minus n, which is now And these just cancel out. This is just, yeah, fix that up. This is just equals to, well, n cancels with this one right here. So n minus n plus 1 equals to 1. So we're not changing anything. So this is the same thing. Oh, this is just having n. I mean, this is just 1 and then plus n minus n. So then, yeah, those just cancel out. And then what we have here is y, and here is x. Like that. So in other words, this is equivalent to our 1 plus xy over y minus x. Like that. So that's equivalent to that. So thus, we can just plug that inside. Yeah, so I'll put thus and then write this as the arc cotangent of this. So we'll just write this out. So now we've made it pretty much match our identity. So thus arc cotangent of 1 plus, or actually put the whole thing in, of n squared plus n plus 1 is the same thing as writing arc cotangent of 1 plus n times n plus 1 over, and put this in a bracket like that, like this, and now this is going to equal to n plus 1 minus n. In other words, now we could apply our identity that we have from part A. So this is arc cotangent x minus arc cotangent y. And in this case, x is n, and y is n plus 1. So this equals to arc cotangent of n minus arc cotangent of n plus 1. And I'm just going to box this out. This is an important formula for this solution. All right, now notice what we have. This is, again, looks like our telescoping sum setup. Whenever you have a subtraction where you're subtracting the next term, that's usually means we're going to be canceling out. Yeah, so continuing further, so this setup is the familiar case which gives us a telescoping series with nth partial sum being, well, let's just write it out. So Sn, because we're going to be summing this up to infinity, so that is the function arc cotangent of n squared plus n plus 1. Again, we're asked to find the series, this right here, so summation. So let's take a look at the nth partial sum. So Sn is equal to, well, arc cotangent of, arc cotangent, let's put a 0 in here. So arc cotangent 0 minus arc n plus 1. So when n is 0, n plus 1 is 1. Arc cotangent of 1. And then the next term is going to be 1 plus arc cotangent of 1, like that, minus arc cotangent of this is going to be 2. And notice here, this cancels with this. So this cancels with this, and we can keep going on and on. Plus, let's do one more here. Arc cotangent of 2 minus n plus 1, or 2 plus 1. Arc cotangent of 3, and remember this cancels with this, and so on, plus dot dot dot. We keep going all the way until arc cotangent of n minus arc cotangent of n plus 1, like that. And put this in a bracket, a closed bracket, like that. And then everything cancels out. This will eventually cancel out. This arc n also cancels out. And all that we are going to be left with is this and this. In other words, let's put an arrow, So this equals to, everything cancels, arc cotangent of 0 minus arc cotangent of n plus 1, like that. Alright, so thus, let's put it all together, and we'll just box this out as well. So that's our Sn. Alright, let's do a better boxing. Alright, so that's our Sn. So now, thus, put it all together, the summation as n approaches infinity, it's from n is 0 as it approaches infinity, of arc cotangent of n squared plus n plus 1 is equal to, well, the limit as n approaches infinity of our Sn, which is this setup right here, arc cotangent 0 minus arc, let's see, right here, so I'm going to write this a bit neater, arc cotangent 0 minus arc cotangent n plus 1, and then all bracket like that. And now that we have this, well, we know the limits here. Yeah, we'll look at these limits actually here. So this part right here is approaching, this is approaching arc cotangent of infinity like that. And if we see our earlier graph, this is approaching 0, because we can see, if you see our earlier graph above here, so right here, as it's approaching infinity, as theta is approaching infinity, this is approaching 0 right here, like that. So this is approaching infinity, and so we have that. I'm just gonna draw that out. So that's approaching infinity, and then when it's at 0, this is at pi over 2. So this is at, I'm going to draw this in red. Let's get this red here. This is pi over 2. So this is at the x1, at the horizontal becomes the vertical. So that's at pi over 2. And just get the black, and let's keep going. And I'll draw it over it again. So this approaches 0, and this approaches, well, this is equal to pi over 2. So in other words, this equals 2, well, pi over 2 minus 0, and equals to pi over 2. So fascinating stuff there. And let's just recall for completeness. Recall here the angle. This is theta, and this is right here. Remember, this is pi. This is 0, and then it goes like this, where this is pi over 2. So at 0 is pi over 2, and it goes to infinity. Let's draw this a bit better. And then it goes like that. But it doesn't curve up, it just keeps going down like that. Alright, so something like that. And this is at pi over 2. Yeah, so that's pi over 2. This is our arc cotangent theta. And as it goes to infinity, it goes to 0 right there. This is going to infinity, and it's approaching 0. And here I just fix up the graph, but yeah, so yeah, as it approaches infinity there, it goes to 0, and then at pi over 2, I mean at cotangent or theta 0, we have arc cotangent of 0 is equal to pi over 2. So yeah, that is equal to pi over 2. So yes, fascinating stuff.